How does our procedure change when we are trying to find the sine of not just x equals to negative 1/2, but the sine of 2x equals to 1/2? How does that change things? So let's look, it does a couple of different changes. So first off, let's remember we are solving this on 0 to 2 pi, which means we need all angles theta from 0 to 2 pi, that when I plug them into here, and multiply them by 2, we get a sine of that angle is negative 1/2. So we're going to start this problem the way that we did before. Sine of 2 theta equals negative 1/2. We'll go look at our unit circle. What two angles have a sine of negative 1/2? Well, 7 pi over 6 and 11 pi over 6 are what we need. Now, you would think that what we want to write is that theta is equal to 7 pi over 6. But when I plug that into here, then we'll get 2 times 7 pi over 6, or sine of 7 pi over 3. Well, that's not the angle I had. It wasn't 7 pi over 3. It was 7 pi over 6, that when I take the sine of it, that is going to be the angle I was looking for. So if I just say that x, or theta, is equal to 7 pi over 6, what I'm really saying is take the sine of 7 pi over 3, which is outside of our unit circle. That's not what we want. So what's actually happening here is that when we get those 7 pi over 6 and 11 pi over 6, it's not that theta needs to equal that. It's that the inside here, or 2 theta, has to equal 7 pi over 6, and that 2 theta has to equal 11 pi over 6. So what is the answer theta that we actually need? Well, how do I get theta by itself? I can multiply both sides by 1/2 in both of these equations. And you can see then that I get 7 pi over 12 and 11 pi over 12 are the angles that theta is going to equal. Now, look at it this way. If I take sine of 2 theta and I plug 7 pi over 12 into this, that's 2 times 7 pi over 12, which is sine of 7 pi over 6, which is in fact negative 1/2 on our unit circle. So the first thing we have to recognize is that we're not solving for theta, we're starting off of the unit circle by solving for 2 theta. The other problem that I have here is that 7 pi over 12 and 11 pi over 12, those are both less than pi, not 2 pi. We need to do a full revolution of the unit circle. So we actually need to find more angles that are related to 7 pi over 6 and 11 pi over 6 by a full unit circle, so that we can get all of the angles from 0 to 2 pi. So let's watch how we're going to do this. Let's take 7 pi over 6 and 11 pi over 6, and let's add 2 pi to those. Now, I know that this will get us outside of the unit circle, but watch what happens when we solve the equation. So 7 pi over 6 plus 2 pi. 2 pi is 12 pi over 6. Get our common denominators. So that's 19 pi over 6. And 11 pi over 6 plus 2 pi, which is 12 pi over 6, is going to give us 23 pi over 6. Now, yes, those are bigger than the unit circle. But remember, this is the stuff off of the unit circle. So now we need to set 2 theta equal to the 19 pi over 6, and 2 theta equal to the 23 pi over 6. And we need to solve for theta. So we'll multiply both sides by 1/2, and we will get our final answers here of theta is equal to 19 pi over 12 and 23 pi over 12. Well, how do I know that those are less than 2 pi? Well, if I take 2 pi and I give it a common denominator of 12, that's 24 pi over 12. Are 23 pi over 12, 19 pi over 12, 11 pi over 12, and 7 pi over 12 all less than 24 pi over 12? Yes. So we actually get 4 answers, and these are all over 12 answers. All right, let's do that again in like one big step and see how we're going to do these a little bit more streamlined. So if I have cosine of 3 theta is equal to negative square root of 3, negative square root of 2 over 2. First thing I'm going to do is look at my unit circle. Where is cosine equal to negative square root of 2 over 2? Well, that's at 3 pi over 4 and 5 pi over 4. So those are my first two angles. So we need 3 pi over 4 and 5 pi over 4 are the starting angles. Because we are going to have a 3 here, we need 3 times around the unit circle. We need to pick up everything that we would get that is a multiple of 3 pi over 4 or 5 pi over 4 as we go around the circle 3 times. So this is our first pair, 3 pi over 4 and 5 pi over 4. Now we're going to add 2 pi to both of these and get our second pair. So that's 3 pi over 4 plus 8 pi over 4, which is 11 pi over 4, and 5 pi over 4 plus 8 pi over 4, which is 13 pi over 4. So here is our second pair, 11 pi over 4 and 13 pi over 4. We need to add one more unit circle because we have the number 3 here. So we're going to add another 2 pi, which is 8 pi over 4. And that's going to give us 19 pi over 4. And add another 2 pi to this guy. So that's going to give us 21 pi over 4. So right now that we have that 3 theta is equal to 6 different angles, we have 3 pi over 4, 5 pi over 4, 11 pi over 4, 13 pi over 4, 19 pi over 4, and 21 pi over 4. And we went around the unit circle 3 times and we got 3 pairs of answers, all that are a circle of 2 pi away from our original 2. Now, remember, this is 3 theta that we have. So we're going to finish this by multiplying both sides of this equation. And we'll just do it with this first one by 1/3 because that will undo the left-hand side. And essentially what we need to do is multiply all 6 of these angles by 1/3. So what is that going to give me? That's going to give me theta is 3 pi over 12, 5 pi over 12, 11 pi over 12. And what I'm doing is I'm multiplying all 6 fractions by 1/3, 13 pi over 12, 19 pi over 12, and 21 pi over 12. So the answers that I would plug in for theta are these 6 answers. And if you look, 21 pi over 12 is less than 2 pi. So it meets our must be between 0 and 2 pi standard. And when I plug in 21 pi over 12, I get something that is a unit circle angle that I can solve to get us those answers. We want tangent of x over 3 to equal positive 1. Now, because this is x over 3, think of this as 1/3 x. So instead of 2 full unit circles or 3 full unit circles, we're only going to look at 1/3 of the unit circle. So where is 1/3 of the unit circle? Well, if we cut this pi into 3 pieces, 1/3 looks, I don't know, roughly here. So we're only allowed to look in sort of this first wedge of the unit circle. Where do we have a tangent of 1? Well, right here at pi over 4, because square root of 2 over square root of 2, y over x, top over top, is 1. So we know that our angle here is going to be 1/3 x is going to equal pi over 4. Now, how do I undo a 1/3 x? I multiply both sides by 3. So what is the answer x that I am going to get here? X is equal to 3 pi over 4.